Assalamualaikum and good day. So today me, Mohamad Fakhrullah bin Hadzir and my partner Mohamad Farhan bin Sukman will present to you guys about assignment 1 is EAA 3840 Traffic Engineering. This assignment consists of 9 questions and we divide by 2, which is me, question 1 to 4 and Syakir Farhan question 5 to 9. Okay, for the question 1, the question asks, traffic volume data were obtained in an observation on a section of rural highway in Kluang, Johor for the period of 120 minutes. Answer the question below. A. The average hourly volume. B. Rate of flow for time interval. C. Maximum hourly volume. And D. 15 minutes interval with the highest volume. And the last one is, what is the rate of flow higher than the maximum hourly volume? For the question A, which is the average hourly volume, we just have to put the formula, which is total interval volume per total interval hour. So we have 71 plus 86 plus 65 plus 143 plus 108 plus 112 plus 94 plus 73 and divide by 2. So we'll get 376 vehicles per hour. For the question B, which is rate of flow for time interval, so the formula is interval volume in 15 minutes will multiply by 4. So the interval volume in 15 minutes is 71. Multiply by 4, we will get 284 vehicles per hour. And for the question C, the maximum hourly volume, which is total interval volume from 9 a.m. to 10 a.m. So we have 108 plus 112 plus 94 plus 73. So we get 387 vehicle. And for the question D, 15-minute interval with the highest volume. So the highest interval volume will multiply by 4. The highest interval volume, which is 143, multiply by 4, we get 572 vehicle per hour. And the last one, why is rate of flow higher than maximum hourly volume? The rate of flow only consider the vehicles observed and data for 15 minutes, which are the worst scenario of all the cases, while maximum hourly volume considers all 15-minute period of the certain hour. Next, we'll move on to the question 2. Data collected on a stretch of highway reveals that the free flow speed is 90 km per hour. Jam density is 112 vehicle per kilometer per lane and the observed maximum flow is 2000 vehicle per hour per lane. So there are 4 questions. Question A, establish the mathematical relationship between flow and speed for the given characteristic. B, estimate the average speed and density when the flow is at the maximum theoretical flow. And C, estimate the maximum theoretical flow and why it is different from the observed volume. The last one, estimate the average speed of vehicle if traffic flow is 1000 vehicle per hour. For question A, establish mathematical relationship between flow and speed for the given characteristics. So we know Q is equal to vehicle per time, K is equal to vehicle per length, and U is equal to length over time. From this, we can get the basic formula of Q is equal to U multiplied by K. But when the cars travel faster than the maximum flow, the flow, Q, decreases as there are less cars passing a point, or in other words, the density decreases. Hence, we get the formula Q is equal to U multiplied by Kj minus by Kj over Uf divided by U power of 2. From this equation, at any given point of flow except maximum flow, there will be 2 speeds, one above the maximum flow and the other one below. And for the question B, estimate the average speed and density when the flow is at the maximum theoretical flow. So during the maximum theoretical flow, the average speed is half the free flow speed. Hence the equation is UC is equal to UF over 2 is equal to 90 over 2, that we can get 45 km per hour. To find the density during that flow, we will need to use the formula of U is equal to UF minus by UF over Kj multiplied by K, which is 45 is equal to 9 minus by 90 over 112 multiplied by K. By solving this, we can get K or, or the density, that is K is equal to 56 vehicle per kilometer. Okay, next we will go to the question C. Estimate the maximum theoretical flow and why it is different from the observed volume. So we need to use this equation, which is Q is equal to U multiplied by Kj minus by Kj over Uf multiplied by U square. So we can get Qc is equal to Uf divided by 2 multiplied by Kj minus by Kj over Uf multiplied by Uf divided by 2 square. Hence, we get the QC is equal to 45 multiplied by 112 minus by 112 over 90 multiplied by 45 square. So we get the QC, which is equal to 2520 vehicle per hour. And from the question, QC observed is 2000, whereas the maximum theoretical flow is 2520. The theoretical is larger than the observed is because in the calculation for theoretical, the headway of the car are assumed to be the same as during jam situation. With a shorter headway, more cars are able to theoretically pass by one point on the road. Hence, the theoretical flow is larger than the observed QC. And when Q is equal to 1000, and using the previous equation, which is Q U multiplied by Kj minus by Kj over Uf multiplied by U square, with Kj is equal to 112 and Uf is equal to 90, we can get that 1000 is equal to U multiplied by 112 minus by 112 over 90 multiplied by U square. Solving this equation, we can get U and with two different speed for the same flow, which is U1 is equal to 10.051 km per hour and U2 is 79.949 km per hour. And U1 is the flow below the theoretical maximum flow, and for the U2 is the flow above the theoretical maximum flow. Okay, next we will move on to the question 3. The table below describes the sample of travel time and vehicle stop delays obtained from the total volume of traffic on major roads leading to the city center. The length of the road section tested was 5 km. Calculate the average travel speed and running speed based on the information given. Also determine the average delay based on the running speed if the free speed limit is 70 km per hour. For the answer of A, which is average travel speed, the formula is distance divided by total journey time, which is including the delay. So this our distance is 5 km multiplied by 1 hour, which is 60 minutes, divided by 47 minutes. So we get 6.38. And B, average running speed. So the formula is distance divided by total journey time delay. So 5 km multiplied by 1 hour, which is 60 minutes, divided by 47 minus 19.8 minutes. So we can get 11.03 km per hour. And for C, average delay, the formula is running time at running speed is equal to distance over average running speed. So distance is 5 km and the average running speed is 11.03 km per hour. We have to multiply by 1 over 60 and multiply again 1 over 60. So we can get 1631.91 seconds. If based on limit speed, 5 km divided by 70 km per hour times 1 over 60 times 1 over 60, we can get 257.14 seconds. If the congested delay, it is equal to running time at running speed minus based on limit speed. So we can get 1374.77 seconds. So if the average delay is equal to delay divided by total vehicles, so we get 1374.77 seconds from before. We'll divide by total vehicles, which is 70 vehicles. We get 19.64 seconds per vehicles. Okay, next we will move on to the question 4. A study of free wave flow at a particle site has resulted in a calibrated speed-density relationship as follows. U is equal to 50 multiplied by 2 minus 0.018 k. For this relationship, determine A, the free flow speed, B, jam density, C, maximum flow, and then D, density when flow is at quarter of the maximum flow. So, sketch the flow density relationship and show all relevant data on the diagram. So, to answer the question, for question A, free flow speed, or we can call it as UF, when the density K is equal to 0. So, first of all, uh, from the previous equation, we will get U is equal to negative 0.9 K plus 100 if we expand it. So from there, we have just to change the U is to UF, and it is equal to negative 0.9, and we insert the K, which is 0, plus 100. So we get UF is equal to 100 km per hour. For question B, jam density, or we call it Kj, when speed, which is U, is equal to 0. And for we use the same formula, but we change the K to Kj. So U is equal to 0. Is equal to negative 0.9 Kj plus 100. So we search Kj, 0.9 transfer to the right. So 100 over 0.9, we get 111.11 vehicle per kilometer. So the maximum for the maximum flow, maximum speed or speed at capacity is UC. From the graph, you can see if we want to get UC, if we want to get QC, we have to get UC first. So for the UC is equal to UF over 2. And UF is equal to 100, which we get uh, from just now. So we divide by 2, we get 50 km per hour. So we use the formula of Q is equal to U multiplied by Kj minus by Kj over UF multiplied by U square. So from the formula, we just change the Q to QC, U to UC, and the rest is the same. So we insert all the data, which is QC is equal to 50 multiplied 111.11 minus 111.11 over 100 minus 50 square. So we get the 2777.75 vehicle per hour. And for the last question, the which is they ask the density when flow is quarter of the max flow. So we can use the equation Q is equal to U multiplied by Kj minus by Kj over UF multiplied by U square. So we change the Q to Q1, which is U multiplied by Kj minus by Kj over UF multiplied by U square. So we get that the Q1 is 694.44, and then let the U and multiply 111.11 minus 111.11 over 100 and multiply U square. So we arrange it, we will get 694.44 is equal to 111.11 U minus by 1.11 U square. So we arrange it, we will get the a quadratic equation, which is 1.11 U square minus by 111.11 U plus 694.44 is equal to 0. And if we calculate it using calculator, we will get 2U, which is the U1 is equal to 93.4 km per hour, and U2 is equal to 6.70 km per hour. And if you are wondering why is there 2U, because if we look at the above graph, we can see that if we pull the Q1 above, we will get a two number of u, which is u1 at the above one and the u2 at the below. And then we will get the u, and we will use the same formula from before, which is u is equal to negative 0.9k plus 100. And we calculate it using u1 and u2. Include the u1, which is 93.4, is equal to negative 0.9k plus 100. And if we arrange it, we will get k1 is equal to 7.33 vehicle per kilometer. And for the u2, we insert 6.70 for the u2, and then we will get the k2 is equal to 103.67 vehicle per kilometer. And then the question asks for to draft all the data. So we will draft a graph for speed, which is u, over versus density, which is k. So we know that the data is all in a negative value. So we will draw one line, which is the blue one, something like this, and we will get for the UF is equal to 100, like we calculate, and then the KJ, which is 111.11, and for the UC that we have calculated, which is UF divided by 2, and we get 50. We will draw UC at the half of the graph, and then we'll put it and until they touch the line, and then we will get the KC. And then for the U1 and U2, we will put it at something between the 50 and 100, but near the 100 because the value is 93.4. And for the U2, the value is 6.70, so something like this. And then we will get the K2 and the K1, which is K1 7.57 and the K2 103.67. That's all from me. Thank you.
Alright, Assalamualaikum and hi everyone. My name is Mohamad Syakir Farhan bin Mohamad Sukman. So I will be explaining about the answers for the question 5, 6, 7 and 9. Alright, so basically let me tell to you about the question 5 first. Alright, so let me read the question for real quick. In one traffic flow, 30% of the vehicle move at a constant speed of 60% is 60 km per hour, 30% at the speed of 80 km per hour, and the rest at the speed of 100 km per hour. An observer vehicle moving at a constant speed of 70 km per hour with a current of 5 km and cut by 17 vehicles more than the number it cut. When the observer moves against the current at the same speed and distance, the number of vehicles found is 303. Right, so this question asking for two answers, which is the first question is determine the traffic flow rate and its mean speed, and the second question is the calculate the number of cars moving at the speed of 100 km per hour that overtaken the observer vehicle. Right, so let's move on to the next page, which is the answers page. Right, so this one is the for A's answer. Right, so 60 km per hour consists of 30% vehicle, while the 80 km per hour is also 30%, 30%, and their 100 km per hour is consists of others value, which is 40%, 40% out of the number vehicle. So the total cars is overtake is 303, and we can find that 91 vehicle for the 60 km per hour and 91 vehicle for the 80 km per hour, and the rest is 121 is for 100 km per hour. From the question, we know that the observed vehicle is 70 km per hour, distance is 5 km, and the overtake test vehicle is more than 17 vehicle, while the test vehicle have passed is unknown. Therefore, from the equation 1, we can find the x unknown, which is 143. From that, we know that the overtake test vehicle is extra 17, so 143 will be add up with at 17. Therefore, we can have the sum of 160 for the overtake test vehicle. Therefore, we can find the flow rate, which is Q is equals to X is plus plus Y1 is minus Y2 is close the bracket over by TA plus TW. Right, I think that's correct. Okay, so the time is same, so which is add up by 0.0714 hour and another 0.0714. So from that, we can get the Q for the car is 224.90 vehicle per hour. So we move on to the mean speed. As the question does not state any specific mean, so we find for both, which is time mean speed and space mean speed. Time mean speed with the formula, the total of time, total speed over n, and we will get the answer is 81.98 kilometer per hour. So while the space mean speed with the formula of nd over total of time, so the answer will be the 78.41 kilometer per hour. Alright, so let's move on to the next page, which is for the question B. Alright, for question B, we need to find what are the numbers of vehicles that drive at 100 kilometer per hour have overtaken the test vehicle. Therefore, from the percentage, we know that 40% of the vehicle is driven at 100 kilometer per hour. Therefore, 40 over 100 times by the total vehicle which have overtaken the test vehicle, which is 160 vehicle, and we get the answer is 64 vehicle that overtake the test vehicle at the speed of 100 kilometer per hour. So I think that's it for this question 5. Alright, so let's move on to the next question. So before that, if you're wondering where is question 6, so basically question 4 and question 6 is constantly the same. So question 4 is already answered by my partner, which is Fakhrullah. He already explained about the question 4 for in his part. So basically I will just skip the question 6 because the question is same. So let's move on to the question 7. So alright, so let's I read the question 7 for real quick. The maximum free speed of a road is 80 km per hour. The current traffic flow is 1,200 vehicles per hour, with 60% private vehicles, 20% commercial vehicles, and 20% buses. The average distance between vehicles by type in a stagnant flow condition is 8 meter for private vehicles and 12 meter for commercial vehicles and buses. The load rate of private vehicle is 2.0% per vehicle, and buses are 35% buses, and the relationship between speed and concentration is linear. If the use of private vehicle is restricted, almost half of private vehicle users will switch to buses. So the question asked is, what is the maximum possible flow capacity of the road in question before user transfer takes place? And the next is the maximum possible flow capacity of the road in question after the transfer of users. The last one would be the average speed of traffic flow before and after the user migration. Alright, so let's move on to the next slides, which is for the calculation part. Alright, for this part, so the first question. So for the first question, we took the 60% of private vehicle and times 0.2 for the occupancy of private vehicle, then we plus the 20% at commercial vehicle with times occupancy of vehicle, which is 0.2, and then we plus the 20% of buses with times 35 for the occupancy of private vehicle. So the answer would be 8.6. Then we times 1200 for the current flow, and we get the answer is 10320 PCU per hour. So let's move on to the next part. So the next question. So the question asks to find the maximum possible flow of the road in question after the transfers of users. So the question states that almost half of the private vehicle will uh, switch to buses. So 60% divided into two, so we get 30%. So the 30% will be the private vehicle new value. So the 30% we times with 0.2, and then we plus 20% times 0.2, and then we times with 0.2, and then we plus 0.5 times with 35, which is the 30% is already added from private vehicle. So we get the answer is 18.5. And then we times by 1200, and then we will get the answer is 22200 TCU per hour. Right, so for the last question, the question asks for average speed of traffic flow before and after the user migration. Okay, so how to solve the answer? So basically, we just total up the before and after value, and we divide it into two. So we will get the final answer is 16260 PC per hour for the final answer. Alright, that's all for question 7. Alright, so move on to the next question, which is question 8. So let me read the question real quick. In a road section, when the traffic flow is 1,400 vehicles per hour, the average speed is 20 km per hour, and when the flow is equivalent to 1,300 vehicles per hour, the average speed increases to 25 km per hour. If the relationship between UK is linear, so the continuous question is A, B, C, right? So, what can we get the information from here? So, what can we denote from here? From the previous question, we can see that in first condition, Q1 or flow 1 is 1,400 vehicles per hour, corresponding to its speed U1 is 20 km per hour, whereas for situation 2, the flow is 1,300 1,300 vehicles per hour, corresponding to its speed, which is 25 km per hour. Alright, so let's move on to the next page, which is the question and answers part. Alright, so the first question is estimate the traffic density for both flow conditions. So we'll start off by answering the first question, A, which is estimate the traffic density for both situations. Okay, right. The question is very straightforward. So use the formula U equals to Q times K, while U is the speed and Q is the flow. We want to find the K, which is the density. So we will calculate the density for both situation. Use the formula K1 equals to Q1 over U1, which is 70 vehicle kilometer per hour. And for situation 2, the same method as previous situation, and we will get when we will get the answer, which is 37.14 vehicle kilometer. Sorry, 37.14 vehicle per kilometer. All right. So let's move on to the next page for question B. Alright, so estimate the maximum flow that the road section can bear. So in order to find QC, we must find the free flow speed, which is UF and KJ, which is the jam density. Based on the UK relationship graph, we will use the equation U equals to UF minus UF over KJ times K. Basically, the equation here refers to linear graph which corresponding to Y equals to C plus, Y equals to MX plus C. Where UF is the y-intercept, whereas UF over kg is the gradient. In order to find UF over kg, we can use the previous relation provided where U2 minus U1 over Q2 minus Q1. we will also get the gradient here. So the answer we will get for the gradient UF over kj would be negative 0.456. Right. So plug in the number which is the gradient in the equation. You will get U equals to UF minus 0.456k. So after that, you can plug in the numbers from previous situation where you can use U1 and K1 or U2 and K2 uh, to find UF. So here we will use U1 as an example. Uh, use as an example, so plug in the number 20 equals to UF minus 0.456 times by 70. So you will get the UF, which is the free flow speed, equals to 51.92 km per hour. After that, you will find the jam density using the gradient equation, which is 51.92 km per hour. Sorry, gradient equation 51.92 over kj equals to 0.456, where kj we will get 113.86 vehicle over kilometer. That is our value for gym density. Uh, After you find the UF and kj, we will start off by finding the QC, which is the maximum flow that we want to find. So using the question from UK relationship graph, where uh, Q equals to U times Kj minus Kj over UF times U squared. Uh, so here we can see that it is quadratic graph. So plug in the numbers, we will get the answer is 1477.91 vehicle per hour. Alright, so let's move on to the last question for question C. Alright, so this question asks about the average speed of the vehicle when the maximum flow is reached. So uh, therefore, the average speed of speed is equals to UF over UF over 2. So straightforward, 51.92 over 2. So we will get 25.96 km per hour. So that is our speed at maximum flow. Alright, sorry for the miss miss misconception about my, because I have lips around my mouth. All right, so let's move on to the next question. So to the last question, which is question 9. Right, so let me read the question real quick. Evaluation of a set of traffic flow data on a highway shows that the speed when free flow is 90 km per hour, the stop flow tap density is 112 vehicle kilometer per lane, and the maximum observed flow or actual capacity is 2000 vehicle per hour per lane. If the velocity density relationship is linear, so the question, there are three questions, which is the question A, determine the estimated velocity and density when the flow reaches the theoretical capacity as well as the theoretical capacity value. The next question is B, which is explain why the value of actual capacity differs from the theoretical capacity. The last question will be estimate the average traffic flow speed if the flow is 1000 vehicle over hour over lane. So what can we get? What information can we get from here? So of course, if you can see on the question, we will get the QC, which is 2000 vehicle per hour, and the UF, the flow, which is 90 kilometer per hour, and the KJ we will get the value, which is the density is 112 vehicle per hour. So let's move on to the next page, which is the answers. Alright, start off with the first question, which is we need to find the QC. Alright, so start off with find UC. So the same method used as the question 8 for the previous question. So we will use UC. UC formula is UF over 2, which is 90 over 2, and we will get the answer is 45 kilometer per hour. And then we proceed with to find the value kg value. So we'll get the kg value is 56 vehicle per kilometer. Then lastly, this QC formula is very straightforward. So we will just times the UC and KCs together, and we will get 2520 vehicle per hour. So alright, so move on to the next question, which is B. So the reason why the value of actual capacity differs from the theoretical capacity is that we assume the maximum theoretical flow and speed capacity is the same during jam circumstances. Alright, so let's move on to the last question. So when Q is equals to 1000 vehicle per hour, what is the value of U? Right. So we will use the equation Q is equals to U times kj minus open bracket kj over UF close the bracket times by U squared. Right, so just plug in the numbers, replace the Q with 1000, and then we just do the basic math, and then we will get the U1 is equals to 79.95 km per hour, while whereas U2 will get 10.05 km per hour. So that's it for this entire project and questions. So that's it for our group. Thank you.